We are very excited to welcome Lauren Showalter and Brian Stone from Axiom Data Science. They'll be presenting Making the Data Work for You. Lauren is the project manager at Axiom Data Science. She has a master's in marine science from the University of Alabama and has worked in data management space since the Deepwater Horizon oil spill in the Gulf of Mexico in 2010. She uses her background in marine ecology and management to improve availability and access to research data. She has managed the development of a large-scale data repository and interdisciplinary data programs focused on the Gulf of Mexico region, ranging in topics from oceanography to community resilience. Brian Stone is a senior software engineer at Axiom Data Science. Brian has a Bachelor of Arts in Art Studio from Colorado College in Colorado Springs. He has developed web-based applications since 2004 and specializes in web design and usability concepts. Prior to his work at Axiom, Brian was the primary web administrator for the Anchorage Daily News and Alaska.com, and he created a variety of interactive maps and graphics to supplement newsroom stories. At Axiom, he creates cross-platform web-based spatial planning applications that allows users to interactively explore multiple large scientific data sets across time, space, and depth. Thank you guys both so much for joining us. Lauren, I am going to promote you to presenter, so you can go ahead and share your screen. You should be getting that prompt now.
Great, thank you. Okay, you seeing everything?
I sure am.
Okay, wonderful. Hi, everybody. I'm Lauren Showalter, project manager with Axiom Data Science, and I'm going to give you just a short overview of the Axiom Data Portal, the SECOORA Data Portal, and then I will pass it over to Brian for a demonstration. So as Abby just said, the SECOORA mission here, as Axiom as the DMAC partner for SECOORA, helps them realize this mission through data management. So today I'll give you just a short overview, a couple slides of the purpose of the data portal, and then I'll pass it over to Brian for a demo of new and upcoming features, and then we'll have some time at the end for question and answer. So this is the front page of the data portal. You can access it through that URL. It's a customizable data environment that allows scientists, managers, and the public to discover, access, and interact with coastal ocean data. So you can see data on a map and compare, or see data through our data catalog. So the data catalog looks like this. It's a place you can go and search for data in the SECOORA data system. You can then add it to a map to compare it, or download it, and download the metadata from here as well. So the SECOORA Data Portal, what is the purpose of this? Why did we build it? Why is it here? So we wanted to support data exchange, analysis, integration, collaboration, and we wanted to have various capabilities for different users. So some users just want a place to come and see data on a map. Some want to make comparisons or share and save data, or publish data to archive. So we have a variety of possibilities through the data portal. And there's a lot of data in there, and more coming in every day. So there's a couple different aspects to the data portal. There's the map, so you can visualize data from different sources. You can overlay different sources on this map and visualize it that way. You can search data in the data catalog and download metadata and the data files from the data catalog, or you can create data views, which are a way to compare different data sets on a map and through charts. So Axiom supports the entire data management lifecycle. So that starts at when scientists go out to collect data. We help with getting real-time data in, quality control of data, and then once that data is collected and the scientists do their hard work, we can use another aspect of our system called the research workspace to house data, and you can share it with various members of your team, even if you're not in the same location. The research workspace also has a place where you can go in and create ISO standard metadata for your data products. which will allow you to archive and preserve data with various archiving centers. So the National Centers for Environmental Information, Data One, and publication to the SECOORA Data Portal. The data can then be accessed, which is the whole point, making this data available and open to the public through the SECOORA Data Portal and through our ERDAP service, which allows for subsetting of data. And then people can then reuse and transform the data via Jupyter Notebooks and other data analytic techniques. So we have a variety of different data categories. You can see all of these here. Some of these come in real time into the system. Some are loaded up later, depending on the type of data collection that you are doing. And so now we're going to go through the data portal with Brian. So thank you very much. And again, I'm Lauren Showalter, project manager, and Brian is our senior software engineer. And our emails are here if you ever want to contact us with questions. So it is time for the demo. And here is the portal.
Great, thanks. Brian, you should be updated to presenter.
Okay, great, thank you. Just make sure I get this right. Are you seeing the front page?
Yeah, we are, it's perfect.
Okay, great. Okay, so I was going to basically walk through different ways to use the data portal using a couple of different scenarios and try to highlight some new features in the data portal if you're already familiar with it. So this is the front page. This is accessible from the main SECOORA website. The new front page has a little mini portal on it that you can jump into this, and there it's highlighted on various places in on the website. This top nav bar remains throughout. So any page you're on, you're going to see this top nav bar. This data portal button on the left side with the little house takes you back to this page. Catalog takes you into a search interface where you can search on tags, free text search. Map is a place to compile data layers and look at them together. Data views, as Lauren mentioned, is a way to look at time series data and compare it to other time series data. Downloads is a new feature. This is a way to collect a bunch of downloads and have them all in one place and then potentially share them with another user. Settings, this is where you can control your units, your base map, stuff like that. Share is a way to share any view you're looking at. So if you have a map that you like, a data view you like, if you've zoomed into a particular area of interest in a time series plot, you can share it with another user using this share button. It's behind my little thing here, but there's also a help button here. So this launches you into our help docs, or you can load up a help overlay. The documentation is really good. There's animated GIFs that walk you through various tasks within the portal. So you can see a lot of the things I'm about to demonstrate in a sort of 3-second loop. So if you're forgetting how to, if you've forgotten how to zoom into a time series or something, you can jump into the portal docs and see how that's done. And then feedback, this is really useful for us. This, again, captures the state of the page you're on. So if you're on a particular page and you see something wrong or you see something right or something that should be added, hit the feedback button. You'll get this little form. Type in your suggestion, your name, your email, confirm you're not a robot. And then we all get an email that has your suggestion in it, but it also has a link to the page you were looking at and what you had set up. So if you were looking at, if you were zoomed into a particular area and you think a station is in the wrong place, we'll see that. So you can just refer to the map that you're looking at in your feedback. Down a little further, explore real-time data, that's where we'll start. That jumps you into the map of real-time sensor assets. Search is the search catalog, and gliders is sort of our featured data set right now. That's glider data, and we'll look at that a little later. There's a brief description of the portal that I won't go through right now. One thing that's useful if you come back a lot is the release notes. And this, again, features animated GIFs, a description of everything that's new, etc. So that can be a useful way to see what's changed in the portal. Data views, these are featured data views that scientists have helped us put together. In this case, we featured a lot of hurricane stuff. So these are sort of snapshots of what happened at a particular location or, across a region during an event. And again, these are creatable. You can create these on your own, or you can look at ones that have already been created. Data categories gets you into search, and then there's some other stuff at the bottom. All right, so on with the demo. So I'm going to go ahead and click on Explore Real-Time Data. The other way I could get into the map would just be to hit Map up here. So when I load this up, I get a map of all the assets, all the sensor assets within the SECOORA region. And you can see that there is this hexagonal lattice with some colors, some not colors. The colors represent, if you look at the legend, real-time air temperature. So air temperature data that was collected within the past 2 hours, and it's averaged for stations that sit within the hexagonal bin. I can hover over it to see how many stations are represented, and I can see the past day of data for a few different variables. So here I'm seeing air temperature over time, water temperature, salinity, and that there are 10 stations under that hexagonal area. So that's a quick way to explore. As I zoom in, you can see that the data rebins, and at some point I will get actual stations. So now I get a bunch of dots, and I can do the same thing. So I can hover, and now I get the name of the station that's under my mouse, along with that real-time preview. Some things I can do in the legend. I can change my palette to something a little nicer. Magma. I can also change the scale. So I can highlight, a particular temperature zone. So if I wanted to, sometimes I'll see if, is anything below freezing. And you can just take your top value to 31. You can also change the opacity, which is useful. We'll do that a little later with some raster layers. Moving down, variable types. So this is a little bit involved. Variable types controls what variable is being featured. So right now it's air temperature, but I can switch that to, for instance, atmospheric pressure. Reloads, now I'm getting latest atmospheric pressure throughout the region. Again, I can hover and atmospheric pressure now shows up at the top. This can also act as a filter. So right now I'm saying show all, meaning I want to see all stations that are available. If I were to unselect show all, then I filter out stations that don't have atmospheric pressure. I can also filter by source. Before I do that, I'm going to switch to currents so that I can demonstrate what that looks like. I can also filter by source. So now we've filtered down to, you might not be able to see the drop down. Sometimes that happens on webinars, but basically I've clicked on sources and I can see available sources, and those have been filtered also. So now I'm only seeing sources that have variable type of eastward seawater velocity. So one new thing that a new, I guess, feature or capability is we're now able to much more quickly visualize time series data. And this is particularly evident with some of these profilers. So this is, we're looking at eastward seawater velocity out in the Gulf of Mexico. I can much more quickly than if you knew the portal before. This took a lot longer. Previously, there was a while where you had to load. So I can easily filter in time and depth. So now I'm looking at the upper 20 meters. I can also, I'm going to zoom back out. I can also drag my mouse over the plot to select a particular time period and depth. So I'm going to click and drag, and I'm just selecting that particular area, and you can see the slider bar is updated when I did that. I can go in even further until I start to see individual profiles. And you've probably noticed as I move my mouse around, I'm getting individual profiles for the data that I'm looking at, for the time period that I'm looking at. If I'm looking at bin data, then I'm going to get a binned profile. So essentially, we're looking at weekly bin data. So the profile on the right is a profile for that week at this location. Some other stuff I can do here, in addition to the time sliders and the dragability, I can also just select a time. So if I know of a particular time period of interest, I can use this time selector, find the time period that I'm interested in. I can enlarge the plot. This gives me a much bigger version. And then this particular representation of the plot is fairly narrow, so some of the controls have been hidden under this gear. But I can also look at data by depth, and I can change my time bin. I can also turn off auto scaling if I want to scale the color in a particular way. But so for instance, if I feel like that the binning is too coarse, the auto binning is too coarse, so auto binning chose weeks for me, I can change that to days. It'll take a little longer, but I'll get daily data now. As I zoom in, it's going to remain daily, so I would need to switch back to auto if I wanted it to automatically change that time bin for me. So I'm going to switch back to auto. If I were to change to time series, then now I get a depth dropdown also, and I can see all the available depths, and I can look at a time series per depth. I'll switch back to curtain plots. Another new feature is under downloads. So I'm going to go ahead and select a particular time period. Under downloads, if I were to go to ERDAP from here, that's what we use. We use ERDAP to drive downloads. I will automatically have the depth and time period selected for me. So if I click on CSV, then I'm going to get, I don't even need to go through ERDAP. I'm automatically going to have that time period selected and depth range selected for me. So I don't have to resubset the data on my own if I'm going to work with it in a script or something like that. And then if I wanted to see how ERDAP renders this chart, I can just click on chart. I'm not going to let this load up. These take a while. But so this needs a little bit of setup once you get here, but you can see here that time and Z are set for me to the time period and depth zone that I've selected. Another new feature is queue for download. So this basically just creates a queue of files that I'm interested in downloading and saves them for me, so that if I want to go through and collect a bunch of different data sets, I can have them all in one place, and next time I come back, they're going to be in my queue. So I've added that item to my download queue, and you can see up here under downloads, now there's a 1 because I have 1 file in my download queue. Moving back up on this page, I can also select other variables at this particular location. So again, this is a dropdown you might not be able to see, but when I click on this, I also see that northward seawater velocity is also available. So I can load that up. Again, I can add that to my download queue, etc. If I were to click on the station or sensor buttons on the bottom, then I get a much more detailed view of the data. The chart looks the same, so I'll click on that. So I get the same chart, but I also get a lot more information. So you can see that I'm going to go ahead and expand out to all. This expander button is a quick way to look at all data available. So if you've zoomed in on a particular area and you want to back out and show everything, just hit that expander button. So again, I can hover, get profiles, but now we have this stacked histogram at the bottom. This is showing quality control data. So you can see most of it's green, which means it's good. There's some orange and some red, and you can see at the bottom where we have this, it says Quartad. That's the quality control system we're using for the data, and that green is pass, orange is suspect, red is fail. We also represent missing data and not evaluated. If I zoom in, these are going to rebin and recalculate based on the bin size that I'm looking at. So if I want to look at hourly data, then this might take a second, but I will get hourly bins of quality control as well as hourly bins of data. When I hover, I get a breakdown of the quality control also. So here I'm hovered over this, there's a little area of orange, and you can see that for the profile that I'm looking at, there are 17 data points that have passed and 4 that are suspect. Okay, it said I was paused. It sounds like I'm back though. Okay, so I'm going to hit the back button, or again, I could just hit map and go back to the map. Close this out. I'm going to switch back to atmospheric pressure and show some of these other filters. And so now under sources, there's a variety of sources here, but I can go ahead and iterate through them and see what is available per source. So if I'm particularly interested in PMEL data, I can click on that and I can see that there are a couple of locations with PMEL data. I'm going to switch back to all. I don't always like to go through that filter because it can be hard to read. There's a lot of stuff. So I can also just type in what I'm interested in. So I know that there's a source that has CORMP in the title. And so I can just type that in and you can see that I've filtered down to these stations. Again, I can hover and I can see that there's CORMP, the Coastal Ocean Research and Monitoring Program. And again, I can zoom in and click on a station. So in this case, we're looking at two-dimensional data. We have, for two-dimensional data, this is a full time series. Whoop, I'm gonna back that out a little bit. There's some kind of rough data there. There is, I'm gonna go ahead and blow this up to make it a little easier to look at. Okay, so what we're seeing is that there are seasonal statistics highlighted, and there are some really high highs and really low lows. So I can control those. I can turn them off altogether and just see data by turning off seasonal statistics. But if I want to just get rid of the high and the low to clean up my chart a little bit, I can do that. And I can see that this period here has some data that's really, really low, 885. And I don't know if that's a hurricane or bad data. But again, I could go to the sensor page and see what the quality control looks like. I'm going to back out. What I wanted to show here was that you can, in addition to clicking on the sensor, which gives us the detail about this particular sensor and the quality control, I can also go back out to the station level page. So there's a detail level page per station. Sorry, I clicked on the source. I'm going to go back and bring that up again. Sunset Nearshore is the station. So now I see in one page a map of where the station is located, as well as all of the time series data that's available. There's also some extra metadata on the left side. And these link off to sources where the data came from. And in some cases, you can actually get the raw data from its source in addition to the downloads that we offer. What I wanted to show on this page is that there's an inventory available. So this is showing us just quality control over time, quality control and availability. So I can see that winds go back a little further than water temperature, and I can see when good data is available. These pages are available per source and per variable. So for instance, I could look across the system and see the availability of salinity data for the whole SECOORA region, along with any quality control that's available. And we'll look at that in a minute when we go through search. So sort of broadening, what's a source now? And again, I get a list of all the stations from this source and inventory. This inventory is the same thing as the previous page. It's showing me quality control, and I can change my variable. So I can look at all atmospheric pressure data for this source, or I could look at waves for this source. From here, I can click on a particular station and get the details about that sensor. This leads me into another sensor detail page. Okay. I don't see any questions coming in, so I am going to, we've sort of already started to go into search. There's a couple ways to, yeah, go ahead.
I do have a few questions that have come in. Stephen Myers is asking, are there size limits to downloads?
No. So if you can get it off of ERDAP, you can get it. I should sort of qualify that if I'm not sure if we have any really high resolution data in the SECOORA region. some of those data sets would take a really long time. For instance, in some areas we have, minute data for 30 years, and people have had trouble downloading like full data sets there. For the most part, you shouldn't run into issues.
And then Carrie has asked, when you add something to your download queue, does it stay in there for all time and allow you to download that data anytime you click the button, or is it a one-time use click/download?
It stays there. So it's cookie based, so it's based on the machine that you're on, or you can create a share URL and bookmark it and send it to somebody else. For that share URL, that download queue will always look the same because you can't change it. You can change your session by removing download items after you download them, but otherwise they'll stay there. So I can show you what that looks like. This is that download page, and it offers all of the resources we saw earlier. So I can jump into ERDAF, that's CDF, CSV.
Great, thanks. And Christina has asked, can the portal display current vector plots as well?
Yes, I'm not sure we have any with directional data here. Winds would be an example of that. If you have one in mind, I can check.
Yeah, Christina, if you want to send us, if you have a vector plot in mind, we can see if it's in the catalog. And then one more question, Brian. Ellen has asked, do you offer data as a feature or dynamic services?
I'm not sure I understand the question. We have services that provide data. If you were to go back to that service and the data has updated, you will get the updated data. Hopefully that.
Okay, thanks. And Ellen, if you want to elaborate on that question, I can ask after Brian's done presenting, or we can connect you over email.
Okay. Is that it for now?
Well, one more just came in, and then
okay.
Pretty minor, very subjective, but I'm curious, since Brian said, let's change this to a better color map, if it's possible to change the default color maps to their named palettes, for example, air, water temps default to showing up in thermal.
That is on the list of features that were, so you can, you can change your default under settings, and then new stuff that shows up will use that palette, but that's not parameter based. We have on the roadmap for this year to set defaults per parameter. So salinity would get the proper salinity palette, etc. And that's stuff where you'd be able to control it, sort of like you can control units.
And Paul, we will be sending a recording of the presentation either later this afternoon or tomorrow. And that's it.
Okay, great. So I wanted to get into search a little bit. So this would be a way to jump in, explore some data, but there's a lot more data available, and there's a lot more you can do with the system. The quickest way to get to search data is just to click on Find Data. So you can see I've already been searching for GFS to prepare for the demo. That's a model that's available, but I can search for air temperature, and I can see data layers that are available that I can load up. And I just hit the plus button, and they load right up. So this is loading up a sea surface temperature layer. This is assuming that I know something about that layer. If I wanted to find out more, I would need to click on the actual link here and go get metadata about it. So I'm going to remove that from the map. More extensive searches are available through the catalog. So, oops, I cheat a little bit. All right. Okay, so the scenario that I was going to put together was to explore Hurricane Isaias. SECOORA had, correct me if I'm wrong here, I believe they had a glider that was deployed at the time and was diverted to capture some data about Isaias, and then they quickly deployed another glider. So the first thing I need to do is to find that hurricane layer. So I'm searching for Isaias. So I started to type in Isaias, and I saw that that was available as a search term. I can click on this link and get more information about it. So I can find out where the hurricane track came from. I can download the hurricane track. That's feature data. And I can add it to the map. So at this point, you can see that the map now has 2 layers. And if I click on this little, so I can either click on the map to go back to the map, or I can click on this little arrow. I can see that the 2 layers that are loaded up are SECOORA real-time sensors and Hurricane Isaias. I'll go back to the catalog, and I'd also like to compare this to some model data for that time period. So I'm gonna, once again, search for GFS. So this is the NCEP global forecasting system for the SECOORA region. There are a number of layers available. There are a couple here, and you can see that different time periods are captured. So I happen to know that Hurricane Isaias was around August 1st of 2020. So this first one runs from July 25th, 2020 to March 28th. So has predictions. The next one is for December 5th, 2016 to December 29th, 2019. So that wouldn't cut it, but this first one would. I can click here to get a breakdown of all variables available. So since I'm interested in a hurricane, I think winds would be appropriate. I'll do composite reflectivity. This is a good way to just see the center of the hurricane, and pressure. Okay, so now I have 5 layers loaded on the map, and I'll go back to the map and clean things up a little bit. Okay, so that's a lot of data all at once. Again, I can hover and I can learn more about each data set, but the first thing I'm gonna do is hide everything just to go through one by one. So hurricane, one trick is if you have a bunch of layers loaded up, if you hover over that layer, even if it's hidden, it's gonna show up alone. So I can hover over Isaias, I can hover over sensors, 10-meter winds, etc. So I'm just gonna show these one by one. So I'll show Isaias. So some stuff I can do, I can hover to find out about each, what the storm type, the pressure, wind speed at that particular track point are. I can click on it to get that data would just show up in the lower left. I can also click on Load Hurricane Isaias Data Overview. That's a different portal. That's the Hurricane Data Portal. And if you have a minute at the end, we'll go there and have a look at that. That gives more in-depth comparisons between sensor data and hurricane data. I'm going to leave the real-time sensors hidden for now and add winds. So again, I can click on this and I can select a new color palette. So I'll choose speed, and then I'm going to dim this down a little bit using the opacity filter. Before we go on, I'm going to make sure that we're looking at a time period of interest. So that the area that I'm particularly interested in is right here when it was passing sort of between Jacksonville and South Carolina. And so that happened August 3rd, around August 3rd in the morning, Alaska time. So I'm gonna see if I can locate that time period here. So you can, I don't know if you can see, but it's giving me a preview of the time period I'm gonna select, and I will scroll back to August 3rd. So that updated my wind layer, and it should update all the other layers that are time enabled right now. And I can see here in my legend that August 3rd, 2020, 11 o'clock is selected. So that's pretty good. And I can see that there's really high winds right here near this track point. Okay, now I'm gonna add composite reflectivity. So this is sort of my cloud layer. Choose a better palette for it. And I'm gonna go ahead and move it to the top, move it on top of 10-meter winds. And I'll dim it down a little bit. Okay, so now I can start to get more information. So if I were to hover, again, if I hover over the point, I get the estimated data for that particular time period from the hurricane service, but I can also get the model data. So I'm getting a brief time series for the model data from that particular location. So you can see it's highlighting plus and minus 1 week around August 3rd, which is my selected time period. And then finally, I'll add pressure. And I'm going to, again, choose a different color palette. And it's hard to see the pressure. I'll probably keep that hidden for now, but I just want to show that you can highlight all of that data at once. So now I'm getting a quick comparison, and you can see where the winds peak, the pressure dips, and there's cloud activity for that area. If I click, then I'm going to get a time series. So in this case, it defaulted to the time period, to the most recent data. So I'm going to have to manually select the time period of interest, which was back in August. So this is the time period. So here's August 4th. I can switch to winds. Go back to August 4th again. Okay, and so here we can see the peak winds. Okay, so I'm gonna go ahead and create a data view so I can save this and compare it to some other data. So I can say, I can either add it to my default data view. Everybody gets a default data view, and it's just a place to put data and compare it, or you can create new data views. So I'm gonna call this one Isaias, and I'm gonna save my time series to that data view, and I'm gonna add it to the compare chart. Since we had the atmospheric pressure visible at the time, when I clicked, it's also available, and I can load up that time series, go back to August 4th again, and you can see the dip in pressure. So I'm gonna go ahead and add that to my data view. So now I have two time series available for my Isaias data view. If I click on this, I can see that I have a comparison between the two. And my compare chart didn't retain my selected date, so I'm going to switch back here. And this is the particular time period. And again, I can drag over this to select a time period. That can be a really big time saver. On the right side, I get the individual plots that I selected. And at the top, I get a map of where I selected them from. I can select as many time series data sets as I want from as many locations as I want and compare them. This page can get overwhelming if I try to compare too many at once. But for instance, I can go back to the map and I can try to select a nearby sensor station. See if we can get that to load up. Okay, so that layer is hidden, so I'm gonna bring it back. I'm actually gonna hide all and bring back the sensor layers. Hopefully that wasn't too overwhelming. And I will bring up Hurricane Isaias. So this was our track point that we were interested in, and I'm just gonna see if I can find a nearby station with some data. So this guy looks pretty good. And I wanna grab around August 1st, 2020. I'm gonna select that in my time selector. I'm taking July 31st to August 3rd. And I'm gonna add this to my data view. When I go back to the data view, I'll see the GFS data compared with the real-time sensor data. So here you can see the purple is the overlaid real-time sensor data from FRIP nearshore, and then the green and orange are both GFS data sets. So you can imagine adding up as many data sets as you want. I think we're running a little bit short on time, so I'm going to quickly show how I could add those gliders to this to the map. So I'll go back to the map. Okay, so I am going to hide sensors for now. So we just have our track line showing, and I'm actually going to go back to the catalog and use advanced search. So I want to clear out my search term. I go back to the catalog. So here we get some new search filters, a spatial filter. Scrolling down, there's a temporal filter, and then I can search by data provider and tag. So I'm particularly interested in a spatial filter and a temporal filter. So I'm interested in this area on the East Coast. So I'm going to draw a box around it. And I'm interested, so I can see these data sets on the left side updated. and I'm interested in a particular time period, which is around August. Let's see, I'll take from July 23rd to August 10th of 2020. In this case, I'm just typing in the dates, or I can use the calendar selector, hitting apply, everything updated. Okay, so I'm not seeing glider data. I'm seeing that I have 564 data sets. If along the top here, there are different data types highlighted. So all takes in everything. I could just click on sensor stations, and then it's going to highlight just sensor stations that are available for that area and time period. Same for data layers. Moving platforms is what I want. That's got, this is where the glider data is. So in this case, there are 2 gliders highlighted, and I'm going to go ahead and add them both to the map. Now, when I go back to the map, I've got a lot of layers loaded, so it'll take a little while to load up. Okay, so now we have our 2 track lines and our hurricane. I'm going to go ahead and hide one of the track lines for now. Okay, so I was particularly interested in this area over here because this is where we got our data view from. So I can learn more about what was going on with the glider by hovering over a point. And so I'm going to get a profile for all available variables at that particular location. So at this point, I want to, so this is saying July 27th, and the hurricane came through here around August 3rd. So I'm going to see if I can find some data around August 3rd. And I'm guessing this little loop is where they decided to come back around. So there's some data from August 4th. If I shift and drag, I can draw a little box around this area and zoom way in. And here I can start to, so I'm not going to necessarily go through the whole practice, but this looks like the time period when the hurricane came in. So I can start to learn more about this. If I want to learn more about this and get a better visualization, I can click on the glider title, and I'm taken to the glider detail page. So this is going to load up all of the glider data that was collected over for this track line and give me a few different visualizations. So the first one on the upper left is a map. This is just top looking down, just like we saw earlier. And again, I get a profile and the time period, the time when it was collected. I also get this nice curtain plot on the right. I can hover and get, again, more information. I can see the profile. And then if I scroll down, I get this 3D visualization. So I am using my left mouse button to spin it around, or I can drag with my right mouse button. I can also just set it to auto rotate, and it'll spin around. And I don't know if you noticed, but I can, as I'm hovering over this, the map has a little dot that's being highlighted, and the 3D plot has a little line that's highlighted. So I can sort of line up what area I'm looking at. And that can be a way to orient myself on the 3D map. Okay, so I'm going to turn off auto rotate, and I remember that the area of particular interest was around this loop-de-loop. So I can't subset the data using the 3D plot, but I can using the 2D plot. So if I scroll my mouse over here, I can see that this is the particular area, and I can see based on the time periods, this is the particular time period that I'm interested in. And so I can use this slider to zoom in on that area. And I can start to see what was going on around when the hurricane came through. One thing, I'm not a scientist, but I was interested to see that, trying to select salinity, there was a period here where we had really low salinity. And I'm guessing that was when there was a lot of rain coming down, but I'm not sure. But that's around when the hurricane came through, August 1st. Let me scroll down so you can see where that is on the 3D plot. Once I found what I want, I can also download it. I can send this to somebody else, etc. Going back to the map, I'll just really quickly show you can give this a second to load up. So if I do want to compare glider data to some of this model data, for instance, winds, I can hover and I can see, I'm getting a profile for that for August 2nd, and I'm getting winds for August 3rd. So we're not exactly lined up in time, but we're getting close. So you can look at multiple things at the same time that way. I think the last thing I was going to show was that from this, from the legend, I can jump into the hurricane data portal. This is a separate data product. This is a separate portal, and we've used this to highlight relationship between the hurricane and real-time sensor data collected. So this initially gives you a broad overview of the hurricane, so you can see the track line. And then on the right side, we've gotten where the highest wind speeds were recorded, the lowest atmospheric pressures, and the highest waves. And if I click on any of these, I go to the track point during which time it was collected. And so you can see this, it looks like it was at Easto station. If I hover over it, it's gonna highlight the one on the map, which is just south of the track point. And I can compare it to other stations along that. If I wanna find out more, I can click on that, click on the time series, and I jump right into the time series plot that we were looking at earlier. And again, the time period that I'm looking at has been highlighted, but I can zoom out and look at all, get downloads, etc. The home page has all hurricanes available. All featured hurricanes available. And then this storms drop down has all hurricanes within the system. So you can look at Harvey, you can look at all kinds of different hurricanes and get that same data. Maybe a good time for some questions. I think we're about out of time.
Yeah, Brian, thanks for this great overview. And we did have some questions come in, and somebody talked about the hurricanes and salinity. So I just wanted to state that hurricanes bring a lot of rain, and together with increased discharge from rivers, cause surface salinity to decrease. So that might answer your question.
Okay, cool.
And then we did get a clarification on the earlier question, and it was in reference to bringing data from the portal into other geospatial interfaces. Is that something that actually the portal can do?
Yeah, so depending on what layer you're looking at or what kind of data you're looking at, it sounds like you're interested in data layers. And these are all available over a WMS system. So if you click on downloads, you can get the WMS service. So raster layers only offer WMS, so that would be models and coverage layers and stuff like that. But feature layers also offer WFS. This would be an example of that. So here you can see WMS, WFS, shapefile, or CSV. ERDAP also offers some geospatial capabilities, but not as robust as a WMS system.
Great, thanks. And this might answer the question. David asked, for real-time sensor and model data, is there a method to automate retrieval for use in forecast models?
Depending on what you want to do, that might be sensor data, I can say yes. So you would probably want to get to know our ERDAP system. So every sensor has this ERDAP link available, and from there you can enter into ERDAP. There's good documentation here. This is a way to automatically retrieve data for time periods and sensor stations. This has a catalog of its own, so it also has all of the stations available in the system, and this drives all of our downloads. So there's a full API around that. For model data, let me pull up a model. this might be a good one to send us a feedback about if there's one that in particular that you're interested in loading up. I'm not sure why that's not loading. Oftentimes we have threads available, but it's not available for everything. So if there is a particular model that doesn't have threads, you would want to talk to us about that.
Great, thanks. We have another question from Yonggang. Can hurricane path info be downloaded from the SECOORA Data Portal? This include lat, longitude, and time of hurricane center?
Yes. So let me do a quick search for that. Let's look at Isaias again. Under downloads, you can download it as a shapefile, a CSV, WFS. And this is, well, hurricane data, you may know, can be hard to work with. It comes in all kinds of different formats. Sometimes the predictions look different than the past stuff. So we've done our best to normalize it. So this could be a good resource, and we'd love it if other people used it.
Great, thanks. If you guys have any more questions, go ahead and type in. Brian, that is it for now. I'm wondering if maybe we could just showcase them the SECOORA Text-a-Buoy while we have 7 minutes.
Oh yeah.
And
so I just clicked on the, oh, go ahead.
I said another question came in. Do you deal with periodic discrete station data and have a changing coordinate, i.e. you have a weekly CTD sampling where depths are not always the same? Can you aggregate this kind of data set?
I feel like I'm not the best person to answer that. I don't know if Jen can jump in.
I don't think we have her connected to sound. So Veronica, I am going to give you our DMAC email address. And if you could email this question to us, we should be able to answer it.
I think the answer is yes, because I think there's a couple stations that have data that's been sporadically collected at different depths and different time intervals. So
great. And Veronica, I have asked Jen Dorton on Google Chat, so she might be able to provide an answer beforehand, but we'll make sure we answer your question on email.
Okay, so this is the new homepage. We just launched it. Again, there's this quick overview map, and it gives you the most recent top wind speed and the most recent top wave height. But the thing that we're going to highlight was Text-a-Buoy, which is really cool. You can click on this. You get a map of all the stations that are available. And then, so if you bring this up on your phone, you can just tap on that phone number and enter any of these keys. So let's see, I'll click on 42003. So if I were to, I'm not on the phone obviously, but if I were to tap on that from this window, it would bring up a text message, and I just need to hit send, and then I get a text message back that tells me latest dew point, air temperature, wave direction, etc.
Great, thanks, Brian. And this is a new product that we just wanted to highlight for folks that go out on the water a lot. This is a great way to get data from your favorite buoy. And we did get an answer from Jen. Thanks for responding, Jen. We can handle this type of data, provided there is good GPS data to go with the CTD cast data. So you can email us at dmac@secoora.org if you guys have any more questions about the type of data we can aggregate. And I am not seeing any more questions. Maybe we'll give it 1 more minute until we close. Lauren, do you have anything to add?
Nope, I am good.
All right, perfect. You're getting a lot of kudos, Brian, super features. So thank you all for listening in. Cool.
Yeah, and just a quick reminder, hit this feedback tab at the top. If you're having trouble with something, yeah, whatever. This is how we learn more about how people use the portal. Yeah, lots of kudos. And so what's going to happen is we are going to take a recording of this presentation, and Lauren, if I could get a PDF of your slides, and we will send it to everybody
that has registered, and it will also be posted on the SECOORA website, so it's something you guys can reference as you dive into the data portal. And I'll make sure in that email with the recording of the webinar to include a link to the data portal so you guys can explore it yourselves. And if you have any questions, please reach out. We're standing by and happy to help. And so Lauren and Brian, thank you so much for the great presentation, and thank you to everybody who attended, and we'll be sure to get the recording out very soon.
Okay, thank you.
Thank you.
Have a great day, everyone. I'm going to quit GoToMeeting now.